Hello, this is second part for mathematics for game programmers courses 3D geometry module. And in this video I will answer this how to calculate whether line array intersects a sphere. And I will show the formula for that calculation. I found this nice explanation of this formula from this blog called Nix blog, and I will provide the link to this video's commentary section. And it's a little multi-part thing forming this formula, and I will not explain this all pages, and I recommend to examine this for your own time. And I will go straight to the end, to this formula, which is called a quadratic formula, and I will explain these elements A, B and C, how these are formed. So you can find this here, and this A is formed by the dot product of D, and the D is the direction of the ray, and also there's O. The O is the origin of the ray, and the C is the center of the sphere, and also there's a R, which is the radius of the sphere. So you need to calculate all these elements, and after that you can and should calculate this determinant, which is used to check if there is any kind of intersection. If the determinant's result is less than 0, then there is no intersections, so there is no sense to continue the calculation. But if it's greater than 0, then you can continue to calculate with this quadratic formula, and you need to calculate both this plus and minus operation. You need two calculations because the sphere can have many intersection types, like if the ray just goes in the sphere but not coming out, or it impales the whole sphere, or it's just coming out of the sphere. Okay, we use this formula, and I will next show you the algorithm which uses this formula. And also I found this nice algorithm from stackoverflow.com. This is made by user named bobobobo, and I will provide a link to this algorithm also. So here is determinations from E, L, C and R, where E is the starting point of the ray, L is the ending point of the ray, C is the center of the sphere, and the R is the radius of the sphere. And using these values, there is calculated D and F, and the D is formed by the L minus E, meaning end point of the ray minus starting point of the ray, and F is calculated by E minus C, so the starting point of the ray and the center of the sphere. So the D means the direction vector of ray, and the F is the length vector between the center of the sphere and the start of the ray. And here's again this I recommend to take your own time to check how this formula forms. Here's the same starting point as in this next blocks, this starting of this formula, forming of this formula, and I will skip the whole thing to this final form of this formula. And this formula is divided to these floats in the algorithm code to A, B and C. The T's are left out because at least for my knowledge they are just user determinate values which represent the point in the race line. And so this A is what gets this D dot T dot product of this D, and B gets the 2 times the dot product of F and D, and C gets the dot product of F and F minus R squared. And also there is this discriminant, which was this, which I forgot to say that this discriminant is formed by this, if I show from this formula, it's this part, this B squared minus 4 times A times C. So this is the discriminant. So it is formed here. And there is the if check. If the discriminant is less than 0, then there is no intersection and the algorithm or the code stops there. But if it is greater than 0, then it will continue, and we take the square root of the discriminant and then make the calculation for both the minus and plus operations. And if I show this from this next formula, the next showed formula, quadratic formula, it means that we do this calculation for both plus and minus operation. And by doing those, we continue these 3 hit cases and 3 miss cases. And like I explained it earlier, the hit case can be impale, so it impales the whole sphere. It can be poke the sphere, so it goes in but not coming out, or it just comes out but never going in. And the 3 miss cases are fall short, so it never reaches the sphere, or it goes past the sphere, or it's completely inside the sphere, never coming in or never going out. And so there's the checks. If the T1 is between 0 and 1, then there is the impale and poke happens. And if T2 is between 0 and 1, then there is the exit wound case. And for other cases, there is miss happening, and these all are in the same. There is no separation from those cases. And next I will show you this algorithm in practice using Unity. This is very simple implementation where I can shoot rays from center of the camera with straight ahead, and I'm trying to hit that sphere. And I can show you the code. It is how it's implemented in the same manner. Like in that algorithm. So we have all the variables, and I have determined the race length to 10. It needs length, so I think it's not the ray in that sense, but like the line segment may be more accurate term for that. So by hitting the space, it forms the ray from the camera's position and from the forward direction by forward vector, and it draws the line from position to straight ahead length of 10, and then there's formed the direction vector, which is the endpoint of that ray minus start point of that ray, and it must be calculated for every axle x, y, and z. And then there's a distance vector, and it is calculated by start point of this camera minus center point of sphere, and also those are calculated for every point, every axle I mean. And here's the deviations, this A, B, and C, and the discriminant same way as in the algorithm. And this always calculates these because I wanna show you the misses also. So here's the calculation and the checks for T1 and T2, and if there's a T1 is true between 0 and 1, there's an impedance poke, and then the sphere gets color red. And if T2 is between 0 and 1, then the sphere got color yellow, and it means that the case exit wound. Otherwise, it's the sphere gets the color red, and it's the miss cases. And I quickly show you, because I'm lack of time, I quickly show you in practice. So when I hit the ray, you can see the ray there. If I can steer it right, you can see it goes impale it. And if I shoot, okay, it sees that it goes there, but it shouldn't. I don't know why it looks like that, but it shouldn't. It should go red if it impales it. Okay, yeah, there's time limit. Okay, for the ray, it doesn't cast multiple rays. If I go inside the sphere and shoot, then it goes yellow, and it's the exit wound case. You can see it doesn't impale it. So using that algorithm, it should work. If I show you the miss case, okay, it goes inside. I don't know, maybe there's some bug in my code or something. But yeah, it should work using that algorithm and do it in practice. But yeah, my time is coming up, so I end this video. Thank you for watching, and I hope it was some sense for you. Thank you and bye.